Section 7.4, Limiting Reactant. Last section in Chapter 7 before we start playing around with some more labs. Limiting reactant has a really specific definition. It's the reactant that limits the amount of product that can be made. If you have two different reactants, one reactant may be in excess, which means it's probably the cheapest of the two reactants, and it's there to make sure that all of the other reactant is used up. But the excess reactant will make a lot of product, and the limiting reactant will limit the amount of product that will be made. It is totally used up, whereas the other reactant is not used up hardly at all, and it controls the amount of products that are made. These are full review questions besides exactly what I just said. Probably made no sense. Let's do an example. We'll explain to you how it's used in the real world, and we'll do another example. We're going to start off with 20 grams of hydrogen gas with 100 grams of oxygen gas. We're going to make water. One of these reactants is an excess, and one will limit the amount of product that's made. We will see which one it is. It may not be the one that you have less of. So we literally have to start from grams of H2O and figure out how much grams of H2 and figure out how much product is going to be made. So we will randomly start with the H2 because it's mentioned first. We want to go to moles of H2. H2 weighs 2 grams. The ratio is 2 H2Os over 2 H2s. And you want to end up with grams of water. Water weighs 18.0 over 1 mole, and we get a number of 180.0 grams of water can be made. We're going to do the same with oxygen. So we can see that the oxygen will produce less product. The oxygen will limit the amount of product that's being made. All of the 180 grams of water hydrogen can make will not be made because the oxygen is limiting it, hence limiting reactant. To fill in those blanks, oxygen produces the least amount of product. It is the limiting reactant. Not all of the H2 will be used up. It is called the excess reactant. So you're probably thinking, what's the point of all this? Well, there's actually a really good point in this. It's probably the most realistic thing we'll do in Chemistry 11, to be honest. If you're a massive chemical manufacturer, a drug manufacturer, and you're making a little blue pill that on a global scale is going to sell hundreds and hundreds of millions of units, and you're off by a tiny little bit in one of your reactants, say you have too much of one thing, that's hundreds of millions of dollars you're going to be wasting or environmentally putting into the landfill and paying tremendous amounts of money for it. So you want to use stoichiometry and the idea of limiting reactants to mix the exact amount of each reactant so you can try to produce as much product as you can with zero. It's inevitable that something will have to be in excess, but it doesn't have to be in excess by that much. So let's have a look at one more example. This one's all written out already. It'll go pretty fast. Feel free to pause this and copy a few things down once I'm done blabbing here. This is more typical to what you're going to see on a quiz or a test, and there's even an added little twist at the end to push it to the next level, so I'll go slow right there. In this example, we've got a whole bunch of reactants and a whole bunch of products. Now don't think that you have to do what we did for every single product. All you need to do is pick one product, and in this example I'm picking NO. It's easy to add up 16 and 14. There's only a ratio of a 1, so I'm not going to mess up too many numbers. But what you have to do is you have to go a mass to mass or grams to grams question for every single reactant, that's all three of them, to that one product. You have to figure out how much FeCl2 will make NO, how much CaNO3 will make NO, and how much HCl will make NO. Not how much HCl, just the amount of HCl we have, how much NO will be made. And you have to compare those masses. So here they are. Okay, you're probably going to want to pause it and jot this down or just not write any of it down and follow along. Both are going to be effective. So you're going to start off with 56.8 grams of iron chloride. Go through the mole ratio to get grams of NO. Do the same thing with CaNO3, 14 grams, through the mole ratio to get grams of NO. Starting off with 40 grams of HCl through the mole ratio to get grams of NO. And you can see that KNO3 makes the least amount of NO. It's the limiting reactant. It's going to make the least amount of every product. It's the limiting reactant. So yes, this took a little while, but in a 3-reactant scenario, you can still figure out the limiting reactant by looking at one product. Well, here's the little twist. What you are going to be asked to do in a higher level question is to figure out how much in excess are the other reactants. We already know that KNO3 will be gone. It's all used up. There'll be 0 KNO3 left. But there's going to be excess of the other two things, FeCl2 and HCl. So now you have to go from grams of KNO3 to grams of FeCl2 to see how much FeCl2 you actually need. Because you don't need all 56.8 grams of it. You only need a certain amount, and it's got to be less than that. So you're going to start with 14 grams of KNO3. You know that's all used up. Go through the mole bridge to find out how many grams of iron chloride you need. That works out to be 52.7. But we added 56.8. You don't need 56.8. You only need 52.7. So you subtract those, you get 4.1 grams in excess. And what industry is going to say is, well, why am I adding 4.1 grams of excess when I don't need it? So they're not actually going to add 58.6. They're only going to add 52.7, and they know 100% of it's going to get used up, and their waste will be 0. In regards to the other reactant, HCl, we don't need 40 grams of it. We're going to start off with KNO3, go to moles of HCl to grams of HCl. It says, according to the stoichiometry, we only need 20.2 grams. Well, we added 40. So 40 minus 20.2 is 18.8 in excess. That's stuff that we will not add. We're going to save that many grams times 100 million pounds of the product we're making. It's really going to add up to some cost savings. So you're going to do a lab on this tomorrow. It'll be a 2-step process, figuring out what's limiting, what's excess, how much are you going to make, how much did you make. Should work out really well. See everybody then.